we have complex applications which are able to store, process, and transmit cardholder information. You're talking about e-commerce servers. We're talking about processing applications. We're talking about, recently I performed an assessment for an image capturing application, which captures scanned images on form and allows data entry operators to key in those images into a data file. That, if it captures cardholder data, that becomes an application which has to do with PCI compliance as well. So PCI compliance is quite pervasive when it comes to cardholder information. Any application facilitates storage, processing, or transmission, or even display, like I said, needs to get PCI compliant. So this is one of the first important requirements of PCI. I'm sure most of you in this room would know quite a bit about it. Authentication and authorization. You can't have a 2-character password or a 4-character password. You need to have at least 7 characters, alphanumeric, basically. And apart from that, you need to also make sure there are password lockouts. If you enter the password wrong more than 6 times, your account needs to lock out. Session time needs to be implemented to not more than 15 minutes. Things like that. This is basic. This is what most applications need to do, is something like this. PCI also requires a list of users who have access to cardholder information. Let's say you're a bank and you have users who are accessing cardholder information, and you'll probably have a long list. You need to make sure that each of these people actually require to have access to cardholder information, and what kind of access they need to have to cardholder information as well. So also, the authentication and authorization needs to take care of invalid authentication attempts. Let us say, like I said, password lockouts, password resets. A password reset should last for a minimum of 30 minutes is what PCI requires you to do. So authentication and authorization I won't dwell upon because the other sections are quite critical. Now, like I said, this is the underlying message of the PCI. The ultimate objective is to protect cardholder information in storage and in transmission. Now, this can be quite tricky, actually. First of all, you need to realize whether you need to store cardholder information at all. Many times, in many companies, you won't really require to store it. You'll be unnecessarily storing it and increasing your risk most of the time. In many cases, like for example, a data entry company, let's say an offshore data entry company back in India, they would many times not need to store cardholder information. So when they go in for compliance, they would realize that this is not really required for them. So they would purge the data and actually reduce a lot of risk for their customers and themselves in the long run. What elements can be or can't be stored? PCI has a set of elements which can be stored and a set of elements that can't be stored. Like your 16-digit number, which is called the PAN, can be stored, but it needs to be protected. It's called the PAN, the primary account number, the 16-digit number on your card. Name, expiration date, and service code can be stored. The sensitive authentication data, which is the CVV, I'm sure you know what a CVV is, the three-digit number on the back of your card, which is used for authorization, can never, ever, ever, ever be stored. So please make sure that you're not storing CVV, PVV, mag stripe data. Mag stripe data is basically when you swipe your card, the magnetic stripe has a lot of data, which is track data. That cannot be stored. Except for these elements, the PAN needs to be protected as well. So only the PAN can be stored. Now the PCI standards require the PAN to be rendered unreadable. That's the verbatim. PAN should be rendered unreadable. So what are the strategies you can employ for rendering PAN unreadable? It's basically these 3 things: encrypting, hashing, truncation. When we're talking about encrypting, of course, you have this key management which kicks into play as well, because you need to manage keys as well. Hashing, many companies do hashing, but the thing is, when you hash, if you're a merchant, you can never hash because you need that card for chargebacks. And hashing is a single-way process, so it's impossible for you to recover the card number for chargebacks. So merchants cannot, they don't find hashing to be a very, very good way to protect cardholder information. Truncation as well. Many of the processors are adopting truncation because when they process transactions, they won't need to know the card numbers. They won't need the card numbers. You can guess why, because they're just the pipe through which cardholder data is flowing. So they won't need to store cardholder information. So many processors we've been assessing are going in for this option of truncation, where you fuzz out everything but the first 6 and the last 4. That's what's allowed by the PCI. So when it comes to encryption, you also have this added requirement of key management. When we say key management, most of the time, many companies prefer hardware security models. How many of you have heard of hardware security models? I'm sure. Hardware security modules are supposed to be the most safe because your keys never leave the system. Keys never leave. It performs the key management from the system itself. Even a small shake of the hardware security module, and it will switch off, and it will purge all the data inside. Hardware security modules are supposed to be very, very secure. But many times, this is not an affordable option. This is not an affordable option. So there are equally good key management frameworks out there. There are some from Java. There's OpenSSL. There is also Strong Key. There is a Strong Key implementation, which is all open source. So you can probably consider thinking about this for your key management requirement. When it comes to key management, what is the encryption algorithm you should use? Basically, I would suggest PCI has basically talked about AES-256 and SSS-128. Also, apart from this, if you read the NIST document, NIST SP857, it specifies a list of algorithms which will be secure beyond 2030. So you can use that for your reference for key management as well. That is pretty good. So key management, some of the ground rules: don't use passphrases for keys. That I think is pretty simple. Do not use passphrases. Generate strong keys. Automatically generate strong keys. And apart from that, don't store your key encrypting keys in the database. If you store your key encrypting keys, if your database is compromised, then your entire data set is compromised. So that will cause pandemonium. And especially in companies like merchants who will be dealing with cardholder data in and out on a daily basis, key encrypting key in the database, not a good idea. So these are some key management strategies for PCI compliance. Moving forward, this I think is the most underutilized and abused requirement of the PCI, until at least the PCI came along, which is logging. Logging is considered unnecessary overhead, it's considered too much, it's considered not worthwhile. Even if that's true, you're required to do it if you need to get PCI compliant. What application activity has to be logged? First of all, consider what you're logging. You need to log things like this: user info, time and date, system data affected, success or failure. But many times, applications go unnecessarily beyond this. They log unnecessary attempt. They log unnecessary information. Oh. Sorry, folks.
I need to log.
What happened?
I don't know.
Yeah.
ಸ್ವಲ್ಪ ಬೇಗ ಹೋಗಬೇಕು.
Sorry about that technical snag. Yeah, so most of the times applications log unnecessary information. Like processors have a big problem with application logging. Their application logs, they have something called financial switches, which facilitate the payment process, which facilitate the flow of cardholder data. They log everything most of the time. They log everything in clear text. They log the PAN, the CVV, the PVV, the entire track data in clear text. That is blasphemous. That is just unacceptable. So you need to do something about that. So logging of cardholder information should just not be there.